Oh, good day. What brings you by here? It's probably math. Well, that's why I'm here too, and we're going to look at the laws of logarithms again! Previously, when we looked at these, we looked at how to explode them into an expanded form. So to rewrite each expression as individual logarithms. Now we're going to look at condensing things. We're going to take individual logarithms and try to write them as a single log. So this will be all sorts of exciting. These first four examples, we're going to express a single log and then evaluate. And then the other examples, we're just going to straight up express as a single log. There's no evaluation to be done because they'll have variables instead. So when we look at these, we're going to be using those log laws that we developed last time. Things like the log of a product is equal to the sum of the individual logs, or the log of a quotient is the difference between those individual logs. And the other one we had was the log of a power. And that says that we can plunk that exponent out in front of the log. So again, yesterday we went this way through things. Today, we'll be going more this way to take those individual bits and express them as a single log. This is something that will eventually help us solve logarithmic equations as well. So worth noting, make sure you can do this. In a case like this, I have individual logs being added together, and so using the product law, I can say I'm looking at this kind of scenario right there, which means that I can then express these as the log of the product of those arguments. That's that. So now I've expressed it as a single log. I should simplify this a bit. So 50 times 20 is 1,000. I don't need brackets there anymore. And since no base indicated is an implied 10, log base 10 of 1,000 is whatever exponent 10 needs to become 1,000, as we recall. And thus this is 3, in case you need that recollection. That's why. I encourage you to straight up try the others. Go for it. See what you can do. And again, it might be a struggle. You might find yourself confused. You might find yourself stuck. That's okay. Just try things out. Look at the laws of logarithms that are given to you. They should also be on your formula sheet if I'm not mistaken. And I've only been mistaken once. So try these out, see what happens, and then compare to what I write down here. Well, hopefully you paused and you're resuming now, because I'm going ahead. Here I've got a difference between two logs, which means I'm probably dealing with the quotient law right there. So I condense these as the log of their quotient. I simplify inside the brackets to get 36, and log base 6 of 36 is 2, which is because when we take that base to the power of 2, we get that log's argument. Whoa, we've got a bunch of things happening here, but I've got a coefficient in front, which means it must have gotten kerplunked from way out there. And same thing here, this must have gotten kerplunked from there. And then we've just got this single log that's just kicking around doing its thing. Like, okay, you do your thing. Good job, log. So when I tackle this, I'm going to start with that exponent law. I'm going to use that exponent law again here. And there's nothing to do with this last log. Okay. My next step, I would personally just evaluate those those exponents, or those powers, I mean. So 6 squared is 36. 64 to the power of 1/2. You should recall this from a couple years ago, that means we're taking the square root of 64. So that's 8. And that last one's still there. And now we've got these differences and sums happening. So we can use the quotient and product laws of logarithms to condense this into a single log, where we've got a fraction involved. The only thing on the bottom of that fraction would be this 8 because of this subtraction right there. And then on top would be the 36 and the 2 because they're both positive logs. Whoop, whoop. Proceeding with that, 36 times 2 divided by 8 is 72 divided by 8. So I get 9. And log base 3 of 9 is 2. And that's that one. Last one has a bit involved. You don't have to open up the brackets here, but my method does. So there's a variety of ways to tackle this. I'm going to once again start by applying the power law. And I'm also going to open up these brackets at the same time. So this is a minus. Oh, I don't want the 1/3 there anymore because I'm applying the power law. I'm saying that's how we got it. So I'm just going to quickly evaluate those those powers. 12 squared is 144. 6 is just 6. And 27 to the 1/3 is the cube root of 27. So I got 3. And now I can condense this using the power law and quotient law into a single logarithm. The denominator is going to involve everything that had a subtraction in front of it. So we've got this 6 and we've got this 3. And then on top must be the 144. Just take a quick pause here. Note that there's only one log here. And I'm not saying log of 144 over log 6 and log 3. And nor am I saying that this whole thing becomes something like log of 144 over log 6, log 3. The whole point of using these logs is, in this case, in the log laws, is to condense it into a single logarithm. That there's no other logs appearing in the argument there. It's just one. So just always be aware of what the target is when you're doing these. Because if you have that awareness of what the target is, it can make it a little easier to ascertain what path you need to actually follow and whether what you have looks like what you need. In any case, we need to take 144 and divide it by 6 and then divide it by 3. 144 over 12 is 12, so 144 over 6 must be 24. And then divided by 3 is 8. And then this must be 3. Boy. And that's because 2 to the power of 3 is 8, because 3 is the exponent that 2 needs to become 8. These last two examples are again expressing as a single logarithm. Now we've just got variables involved, so we'll have to be playing with that. In this case, that's funny, I guess I could have had this as 2 log x like that. Maybe I should do that for future years. Any case, all I've got is the sum of 2 individual logs, which means I'm going with product law. So then I'm playing with log base 3 of x squared times x. And again, that's by the product law. And then I'm just simplifying inside the brackets. So x squared times x is x cubed. That works as a final answer. Actually, let's just leave it there. Yep, that's done. There is another way to handle this. You could say that you've got 2 log x plus log x, which means that you've got 3 log x's, and then using the power law, you're back here again. Either way you do it is fine. Whatever your heart desires there. Cool. That one's done. And then this other one. Oh my goodness, there's a bunch of things going on. But really just 2 separate logs separated by subtraction, which is the result of applying the quotient law. So let's unapply the quotient law and say that we've got a single log of a quotient, where the denominator of that quotient is this thing that is the log that is the argument of the log we subtracted, and the numerator is the argument of the log that was being added. Given something like this, we should check if it can be simplified. Spoiler, this can be. And to do that, we're going to want to factor the top and factor the bottom. So, your factoring skills come into play. Right, I'm factoring out that. And on the bottom, that. Which means that these x minus 2's can cancel out. And our end result is this. Now, a little technical point, we would have to state a restriction in this case, and that's because we've introduced a denominator when the original expression did not have that. So, as a result of having things in a denominator, we're going to have to say that x can't be -4 or +2. By this original expression, it looks like those are perfectly fine. But from here we can see that no, it would be bad. So we know do that. Yeah. There are actually other reasons to say that it can't be those values, and that's just based on the restrictions on the argument of a log function. But it's not necessary for us to get into here. If you want me to go over it with you, just let me know and I can do that. That sums up this revisit of laws of logarithms. So now we can go backwards and forwards. Give it a try with these practice questions down here. As usual, let me know if you have questions, comments, concerns as you go through them, or if you have questions, comments, concerns on this video. Just bring it to my attention, and that will all be hunky-dory. I will see you in the future. Peace out. A-Town.